This just in: the science of hand washing. Bacteria, viruses, and other microbes are found everywhere. We can easily pick them up from toilets, door handles, keyboards, phones, and from handshaking and fist bumping. Microbes stick to the natural oil on our skin. Soap and water chemically and mechanically act to break down the oil while we rub our hands together, and the water carries away the oil along with the germs. Antimicrobial soaps and gels are used to kill these pesky microbes, but they're not much more effective than hand soap, since not all bacteria and viruses can be killed this way. Antimicrobial soaps also kill off our resident bacteria, such as Staphylococcus epidermidis, which produce chemicals and kill transient bacteria. The risk of increasing microbial resistant strains is a concern as well. Let's talk to our favorite scientist, the professor. Professor, what is soap, and how does it help us to get rid of dirt and germs?
Soap is generally manufactured from potassium or sodium via saponification, which is a chemical reaction that produces fatty acids due to the hydrolysis of fats. Soap cleans because it is a surfactant and emulsifier. Think of the soap molecule as a long hydrocarbon chain called a tail with a carboxylate head. One end of the chain is hydrophobic, water-fearing, and the other is hydrophilic, water-loving. In water, ions are freed, creating a negatively charged polar molecule at the head. The hydraulic carboxylate group, utilizing water molecules, engages in ion dipole interactions and hydrogen bonding. The long, nonpolar hydrocarbon chain of the hydrophobic portion of the soap molecule doesn't interact with the water molecules. Micelles are formed due to dispersion factors between the hydrocarbon chains. Spherical surfaces form in the micelles from negatively charged carboxylate groups with hydrocarbon chains on the inside. Soap micelles, being negatively charged, repel each other, remaining dispersed in the water. Nonpolar oil is insoluble in water. When water and oil are mixed together, the micelles break up the oil molecules, and a new type of micelle forms with the nonpolar molecules inside, pulling the dirt and oil and germs along with them as they get washed away down the drain.
In other words, since oil attracts dirt but does not mix easily with water, soap suspends the dirty oil, making it easier for water to wash it away?
Yes.
What have we learned? We learned that the professor, a self-proclaimed scientist, merely described how washing hands removes dirt and germs. He explained nothing. Rational science explains phenomena using objects. How do molecules pull dirt and oil and germs along with them? What are negatively charged, polar or nonpolar molecules? Do plus and minus symbols in the professor's equations represent some invisible spirit called charge, or some other magical force that pulls molecules and germs together? This is what inquiring minds want to understand. What is the underlying physical mechanism for pull? Rational science understands that all phenomena are the result of surface-to-surface contact between objects. What object mediates this phenomenon?